All right, so we finished up on this example here, and so it says find all real values of x such that f of x equals 0. What that means for f of x equals 0, another way to say that is find the zeros or find the roots. So you should have seen this in Algebra 2. So to do that, you set the function equal to f of x equal to 0, and the function is 3x plus 5, and then you go ahead and solve for x. So subtract 5 from both sides, gives you negative 5 equals 3x, divide by 3, you get x equals negative 5 thirds. So the 0 is negative 5 thirds comma 0, or you write x equals 5 thirds. For this one, for example B here, notice that this is a much more complicated function. So it's a polynomial, and the first thing I notice, it has a whole bunch of x's, so we can't just set x equal to 0 or set the function equal to 0 and then isolate the variable. We have to factor this guy. So I'm going to start by setting it equal to 0 and also factoring out the GCF. So I notice that all the terms have an x in it. So I'm going to factor out the GCF of x, and that leaves me with x squared plus 2x minus 24. Okay, and then this trinomial right here, I'm going to factor that. So I have 0 equals x times, and then I need two things that multiply to negative 24, add to positive 2, and that would be positive 6 and negative 4. So I have x plus 6 and x minus 4. And then you set each of the factors equal to 0. So we have 1, 2, 3 factors that I'm going to set equal to 0. And don't forget about this x out front here, because a lot of students do. So that one should be the easy one. It's x equals 0. The next one would be x plus 6 equals 0. So x equals negative 6. And then the last one, x minus 4 equals 0. So x equals 4. And then when I write my zeros, I usually write them in numerical order. So x equals negative 6, or 0, or 4. Any of those three values would be zeros of the function. All right, so last example here. This is a really important example. A and C are not as important as B and D. So let's do A and C first and just kind of get them knocked out. Basically, the idea is that you need to understand that domain means your input values. So that's your x's here, 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 and here. Those ones are already in numerical order, so you don't have to, but I usually write them in numerical order. So it's the set of numbers 3, negative 1, 0, 2, and 4. All right, and that right there is your domain. It's your input values. This one is kind of an oddball because it's a function. If the function was standing alone on its own, the domain might be a little bit different, but this gives us a little context, volume of a sphere. So if you think about volume of a sphere and you think about the input right there, the r value, that the r stands for radius. So think about the values that you can have that are allowed for radius. Well, I think anything up to infinity is allowed for a radius. 0 would be okay for a radius, that just doesn't form a sphere. But negative numbers don't really work. That doesn't make sense for volume of a sphere. So I'm going to say that it can be 0, and it goes all the way to infinity. So it's basically talking about 0 or positive numbers. Okay, so the domain would be 0 to infinity. The part B and D, these would be more like a test question. You definitely want to know that there's two rules that you have to remember. So yes, domain is input values, but it also has two restrictions. No zeros in the denominator and no zeros in the denominator and no negatives under the radical. So the first one does have a denominator. So if there's no zeros in the denominator, let's just set it equal to 0. I'm sorry, x, let me write that real quick. Okay, so x should have set 0 equal to, okay, so 0 equals the denominator, which is x plus 5. Okay, and then subtract 5 from both sides, and you get x equals negative 5. So that value of negative 5 makes the denominator 0. If I plugged it in for x here, negative 5 plus 5 would be 0. So it can't be that number, but it can be any other number. So usually the way I write it is with math notation. The upside down A means all, and then the double bar R means real numbers, so all reals except x equals -5. Okay, so it can be any number except for -5, because -5 makes the denominator 0. On the next example, part D, it has a radical, so I know that the numbers underneath the radical have to be positive or 0 technically. So what I'm going to do is I'm going to set it equal to or greater than or equal to 0. So I have 4 minus 3x, which is underneath the radical, and I keep saying that they have to be positive. Well, it can be positive, which is greater than 0, or it can be equal to 0, I guess, too. Okay? So then you go ahead and solve that inequality to get the domain. So subtract 4 from both sides. You get negative 3x is greater than or equal to -4. And then here's a little weird part about this inequality. You got to remember that when you divide by a negative, what happens is it flips. Let me change colors here real quick. It flips that inequality right there. Okay, so when you divide by a negative, which I just divided by -3, you got to flip the inequality. So that leaves us with the answer x is less than or equal to, and then a negative divided by a negative would be a positive 4/3. So if it's x is less than or equal to -4/3, that means it goes to the left of -4/3 all the way to -infinity. So it'd be -infinity to 4/3. And 4/3 is included in the set because that makes it equal to 0, and equal is okay. Just can't have negatives under the radical. Okay, so those questions, B and D, would be really good test questions. And that's it for section 1.4.